Welcome to ScholarMatics. So today I'm going to be teaching you how to use the Pascal Triangle to expand binomial expression. So let's get straight to the point. What is a binomial expression? A binomial expression. A binomial expression is an expression with two terms with the addition or the subtraction sign at the center. Or an expression of two terms like x plus 2. This is a binomial expression. We have two terms, x is a term, 2 is a term, and we have the operation sign, that is the plus at the center. 2x minus 3. This is a binomial expression. Here we have the operation sign of minus at the center. Then we have two terms. So sometimes we might be asked in maths to expand these expressions. Like we are given x plus 2 should be expanded in the power of 2. So here, normally in algebra, x plus 2 being expanded of x plus 2. So the solution to this is x multiplies x, x multiplies 2, 2 multiplies x, 2 multiplies 2. So we would have x squared plus x multiplied 2, 2x, plus 2 multiplies x, 2x, plus 2 multiplies 2, we have 4. So the result of this is x squared plus 2x plus 4x, 2x plus 2x is 4x, plus 4x plus 4. Okay, that is alright. We can also expand in the power of 3. So those very easy to do. But what if we're told to expand in the power of 6? We can't keep on expanding. It's going to be very tiring. So Pascal invented this pattern in the form it takes the shape of a triangle for us to get the coefficient of the expression we're expanding. Okay, so what kind of triangle is it? The triangle is gotten in this way. You can just join me as I show you. So the first thing you do, you have 1, then 1 here, 1 here. So at the center you have 2. So you would have something like this. This is how you begin. Then 1 again. Then 1, this 1 plus this 2. You have 3. This 2 plus this 1. You have 3. Then 1 again. Then 1 again. This 1 plus this 3. So you keep following that pattern. We have 4. This 3 plus this 3. We have 6. You write the result at the center of the two numbers you're adding. This 3 plus this 1. We have 4. Then we have 1 again. Then 1. This 1 plus this 5, we have this 1 plus this 4, we have 5. 5. This 4 plus this 6, we have 10. We write the result at between them, 10. This 6 plus this 4, we have 10. This 4 plus this 1, we have 5. Then 1. So try giving the result to the next thing. That is 6. So 1 plus 5 is 6. Okay, 10. 20, 15, okay, 1, 6, 15, 20, 15, 6, 1. So this continues. There's no end to this. So you can continue till you get to 100, whenever you feel like, or whenever you get tired. So we're just going to stop at 60. So this is what you should get. When you are expanding in the power of 2, you make use of this. When you are expanding in the power of 3, you make use of this. When you are expanding in the power of 4, you make use of this. When you are expanding in the power of 5, you make use of this. When you are expanding in the power of 6, you make use of this. When you're expanding the power of 7, you have to continue this pattern. So whatever power you're expanding, you have to get to that level in this Pascal triangle pattern. So how do we use this triangle? Okay, so how do we use the binomial, the Pascal's triangle? So there are many areas where we can use the Pascal's triangle. We can use it in probability, but today we are looking at how to use it in expanding binomial expression. So this binomial expression, we are to expand it in a power of 4. So to expand it in a power of 4, this Pascal triangle here, we are going to use this one, because here we have, when you expand, like I told you earlier, when you're expanding the power of 2, you use this. So we use this line. When you're expanding the power of 3, here we have 3, use this line. When you're expanding the power of 4, after the 1, the next term is 4. In the power of 5, use this line. In the power of 6, use this line. So in the power of 4, these are the coefficients we are going to use. So we have 1, 4, 6, 4, 1. So so these are the coefficients we need. So watch carefully. The first thing we do, we pick the first term. The first term is x, and the second term is 2. So the first term, we pick the first term, that is x. So x we pick the power, that is 4. Then we multiply by the second term, that is 2. Then we start with a 0. So the first term starts with the power, and the second term starts with the 0. So it reduces as we go on. So you leave a little space, then your plus sign, then a little space. So you have the next term will be x. So now 4 is reducing by 1, you have 3, the power. So the second term 2 will increase by 1, plus leave a space, you have x. The next term will be x raised to power 2, the power of 2, multiplied by 2 raised to the power of 2, plus x raised to the power of 1, multiplied by 2 raised to the power of 3, plus x raised to the power of 0, multiplied by 2 raised to the power of 4. So x reduces from 4 to 0, and on 2, the second term increases from 0 to 4. So x raised to the power of 4, then 2, the other term, you start from 0. So the 4 we have to reduce down to 0, and the 2 will increase from 0 to the power in the question. So if it was x plus 2 to the power of 5, then the first term x is going to begin with the power of 5, and 2 will begin with 0, and it will increase down to 5, while 4 will reduce from 5 to, while x will reduce from 5 to 0. So now, what is the use of the space we have left? So in the front of this terms here, we are going to insert the coefficients from the Pascal triangle. The first coefficient is 1 from the Pascal, multiplied by 1. The second term here is 4. The next term 6. The next term 4. And the last term 1. So we used 1, 4, 1. So From here, we just get our answer, we multiply. So x raised to the power 4 multiplied by 2 raised to the power 0. Don't forget, anything raised to the power 0, raised to the power of 0 is 1. So 2 raised to the power 0 is 1. Multiplied by x raised to the power 4. 1 times x raised to the power 4. That is x raised to the power 4. Plus 4. So yeah, 2 raised to the power of 1 is 2. So that we have 2 multiplied by x raised to the power of 3. So we have 2x cubed plus so let's continue. So we have the next term 6. We have x squared 2 raised to the power 2. So 2 squared is 4 multiplied by x squared, 4x squared plus 4. 2 cubed is 8 multiplied by x raised to the power 1, that is 8x. So you should have a good understanding of algebra when doing this. Added with x raised to the power 0 is 1 here. Anything raised to the power 0 is 1. So we have 1 multiplied by 2 raised to the power 4. 2 raised to the power 4 is 16. So we have 16. From here we can get our answer. So we have x raised to the power 4 plus 4 times 2, we have 8s cubed plus 6 times 4, we have 24x squared plus 4 times 8, we have 32x plus 16. So we have used the Pascal Triangle to expand this binomial expression. So let's do something. Let me just show you a bonus tip here. Let's say we are given the question, what is 5 squared? 5 squared. We are told to find 5 squared. Normally, we know 5 squared is 25. So let's say we're to use the binomial the Pascal Triangle to find 5 squared. We would have said, okay, let's make 5 a binomial expression. Don't forget, the binomial expression must have 2 terms. So 5 can turn 5 into 2 plus 3 square. So 2 plus 3 square is still 5 square. So using the binomials on the Pascal Triangle, the coefficient, since we are expanding in power of 2, the coefficient there in the Pascal Triangle is 1, 2, and 1. Since we have our coefficient here, the coefficient of the term here, let's now expand. Don't forget what I told you before. You pick the first term, you raise it to the power in the question, that's 2 raised to the power 2. Then you multiply by 3, the second term raised, then you begin from 0 plus, leave a space. So we have 2 raised to power, then the 2 is now reducing, we have 1, the power is reducing. The second term, the power is increasing, we have 1. Leave a space. So the next term we have 2, the power reduces to 0, and 3, the power increases to 2. So yeah, we reach the end of our expansion. So we can't expand further. So from 0 we can, except we want to go back to the beginning again, reducing 0 to 2, then increasing 2, increasing 0 to 2, then reducing 2 to 0, which is meaningless. So now let's input our coefficient. The first coefficient here is 1. The second coefficient is 2. And the third coefficient is 1. So here we have 2 squared is 4. 3 raised to the power 0 is 1. So 4 times 1 is 4. Plus 2. 2 raised to the power 1 is 2. 3 raised to the power 1 is 3. So 2 times 3 we have 6. Plus 2 raised to the power 0 is 1. 3 raised to the power 2 is 9. So we have 1 times 9, we have 9. So getting the result to this, we have 1 times 4, 4. Plus 2 times 6, we have 12. Plus 9. So that is up. Surprisingly, 4 plus 12 plus 9 is 25. So that is to show, okay, that the Pascal triangle is reliable. Hope you learned something in this video. So for you to get better, go and practice more. So don't just rely on watching the video. Make sure you practice. The best way to know maths is to do maths.